What a great problem we have here. This problem is asking us to now convert from polar form r as a function of theta into rectangular form. Wow. Old friends, cosine 2 theta. I know that cosine 2 theta is cosine squared theta minus sine squared theta, and cosine of 2 theta is 2 cosine squared theta minus 1. And cosine 2 theta is 1 minus 2 sine squared theta. These are old pals of mine. Good to review those. Now, I'm going to choose this first one because I see, if I write this as r equals 3 times cosine squared theta minus sine squared theta, if I could ever get an r in there, I could substitute r squared cosine squared theta for x squared. And if I could give an r squared in there, I could do r squared sine squared theta is equal to y squared. So if I'm going to do that, I have to introduce an r squared that will distribute to both terms here. That's what was guiding my substitution. Now, if I distribute those, then I can set up a substitution going from polar form into rectangular form. But if I add r squared there, of course, I must multiply r squared on the left-hand side. Or not that I added it, but I introduced it, so I introduced it here. So I'm going to have r cubed is equal to 3r squared cosine squared theta minus 3r squared sine squared theta, which gives us r squared. Let me hold off on that. It gives us r squared is equal to 3. This is x squared minus 3y squared. Now, why did I write this as r squared? Because I'm obsessed with r squared. If I can get an r squared, then I can write x squared plus y squared. But this is not r squared. What can I raise this to? Think about a fractional exponent. If I raise this to the 3 over 2 power, let's see, r squared to the 3 over 2. I know this rule, a to the m to the n from algebra is a to the mn. So I've got to multiply those exponents. So that means this is r to the 2 times 3 over 2. The 2's cancel, so r cubed. Oh, that's just a disguised way of writing r cubed. So I'm ultimately going to get here, I can now make my substitution. X squared plus y squared, I'm using this here, that bridge, is equal to 3x squared minus 3y squared. Or you could factor out the 3, either way. But this is to the 3 over 2 power. That's a nice rectangular equation. But what if I specified, write this without fractional exponents? What could I raise both sides to get rid of my fractional exponents? Well, clearly, if I squared both sides, let's see. If I have a to the 3 over 2 and I squared both sides, that's a to the 3 over 2 times 2. The 2's cancel, gives me a to the third. If I square both sides, so I'll square this side as well, then I'm going to get x squared plus y squared to the third power is equal to 3x squared minus 3y squared, and that's to the second power. And what a nice equation that is. And I know it's rectangular. There's no thetas and there's no r's in it. I just felt like I had to include this problem in this section on difficult problems from chapter 9.5. First thing I try to do is probably get rid of fractions. My goal is to convert this into a rectangular equation. So if I have r times 1 plus sine theta equals 2, then clearly I'd probably want to distribute that r, and at least I can say that this is y equals 2. Well, that's rectangular, and that's rectangular. That's certainly not polar necessarily, just a 2. So I'm on the right track. What if I solve this equation for r? If I square rooted both sides, I'd have plus or minus the square root of x squared plus y squared. And you can say to me, hey, there's a rectangular equation. There's no more thetas, there's no more r's. Well, let's clean it up a little bit. If I subtract y from both sides, I'll have 2 minus y is equal to plus or minus the square root of x squared plus y squared. And if I say, hey, let's get rid of this square root, how do we do that? Well, we can square both sides. plus times plus when I square is going to give me plus. But minus times minus when I square is also going to give me plus. So this cleans up to x squared plus y squared is equal to 2 minus y times 2 minus y. Please don't write that as 2 squared minus y squared. So x squared plus y squared equals first 4 outer negative 2y, inner negative 2y is negative 4y, and lastly I get plus y squared. Notice if the y squareds have been good little y's, they go off to number heaven, and we're left with x squared equals 4 minus 4y. So that was a new little technique. I just wanted to show you this. We can substitute for r. Please remember, you're going to have to do plus or minus the square root of x squared plus y squared. Then get it all alone. Then, after you've isolated it, square it, and you drop the plus or minus, and you drop the square root, and then go ahead and clean it up a little bit. This one, too good to leave out of this video. If I'm given this, I know right away that sine of 2 theta, that's an old friend of mine, 2 sine theta cosine theta. So I'm going to use that substitution. At least I can do something here. 4 times 2 sine theta cosine theta. I make the substitution for this. And then I say, well, this means r squared equals 8 sine theta cosine theta. Well, we haven't seen this technique before, but I could, if I'm going to rectangular form, I could say, well, sine is equal to y divided by r, 8 times y divided by r. If I solve this bridge equation for sine theta, and cosine theta, if I divide both sides by r, is going to give me x over r. So r squared equals 8xy divided by r squared. I am obsessed with r squareds. Why? Because I can substitute x squared plus y squared for r squared. I'm going to multiply both sides by r squared, and I get r to the 4th equals 8xy, which of course implies r squared equals 8xy. Remember your algebra. A to the m to the n is a to the mn. So I've done everything legal there. And now, of course, r squared, I'm obsessed with them because I can make my substitutions for them equals 8xy. And that's a nice rectangular equation. I don't see any thetas. I don't see any r's. So we know we've done the job.
I sincerely hope you have enjoyed today's videos.